For today's video, we are going to learn kung paano mag-prove ng trigonometric identities. Now, para sa ating first example, dito we are going to prove that the left side equation, which is secant x minus cosine x, is equal to the right side equation, sine x times tangent x. Now, isa sa mga strategies in proving trigonometric identities is to pick one side of the equation that is more complicated to simplify. Now, in this case, obvious naman that the left side equation is more complicated than the right side equation. So, therefore, ang isimplify natin dito is the left side, and we try to show, find ways and prove that the left side equation is equal to the right side equation. Now, let's start from the left side equation. So, that means mag-start tayo with secant x minus cosine x. So, dito, ang gagawin natin is we're going to simplify this side of the equation and see to it that this is equal to the right side equations. And to do that, ang first natin gagawin dito is we are going to express each term of the given trigonometric expression in terms of sine and cosine. So dito, alam naman natin na to express this given trigonometric expression, kailangan lang natin gamitin ang reciprocal identity ni secant x. Okay? And the reciprocal identity of secant x, that is just equal to 1 over cosine x. So that means i-replace natin si secant x by its reciprocal identity, which is 1 over cosine x. And then i-copy lang natin si minus cosine x. Now, ang next natin gagawin dito is we are going to combine the two fractions into a single fractions. And to do that, ang gagawin lang natin is we are going to subtract. I-subtract lang natin yung dalawang fractions. So, in subtracting two fractions, ang first natin gagawin is find the LCD. And the LCD of the two fractions, or the least common denominator, is, of course, that is just equal to cosine x. Now, itong si cosine x, by following the process on how to subtract fraction, ang gagawin natin sa denominator is, of course, i-divide natin sa kanilang denominators and then i-multiply natin yung quotient sa kanilang numerator. So, let's start with the first term, So, cosine x divided by cosine x, that is just equal to 1. Then, 1 times 1, that is equal to 1. And then, dito sa second term, same process pa rin, Cosine x, i-divide natin sa denominator ni cosine x, which is 1, So, cosine x divided by 1, that is equal to cosine x. Then, multiply it by the numerator, cosine x, that will give us minus cosine square x. Okay. Now, ang next natin gagawin dito is, of course, alam naman natin na itong si 1 minus cosine square x, that is a Pythagorean identities, So that means we can use the equivalent identity of 1 minus cosine square x, which is, of course, sine square x. So that means i-replace natin si 1 minus cosine square x by sine square x, for the numerator, then over cosine x. So this time, we can break down natin yung given fractions into sine x times, of course, times sine x over cosine x. Now, actually, we're almost done because simplifying this one further will give us sine x, sine x times the equivalent identity of sine x over cosine x, which is a quotient identity, and that is equal to tangent x. So therefore, we'll already prove that secant x minus cosine x on the left side equation is equal to sine x times tangent x on the right side equation. And that's the end of our proof. Para sa ating second example, Let's prove that cosecant theta minus cotangent theta is equal to sine theta over 1 plus cosine theta. Now again, in proving trigonometric identities, ang first nating gagawin is to pick one side of the equation that is more complicated to simplify. Now in this case, ang pipiliin natin to begin with is on the left side equation. So that means mag-start tayo with cosecant theta minus cotangent theta. Okay? So again, ang rule of thumb natin in simplifying trigonometric expressions is to express each term of the expression in terms of sine and cosine. So to do this, first cosecant theta, gagamitin natin yung reciprocal identity niya, which is equal to 1 over sine theta. And for cotangent naman, we are going to use the quotient identity of this one, which is equal to, cosine theta over sine theta. Now, this time, ang gagawin natin is we are going to subtract the two fractions. So, combining the two fractions, ang gagawin lang natin is, of course, copy the common denominator. Okay, let's copy the common denominator, which is sine theta, then subtract the numerator. So, that is 1 minus cosine theta. Now, at this point, ang pwede natin gagawin dito to simplify this one further is by multiplying, both numerator and denominator by the conjugate of 1 minus cosine theta, which is 1 plus cosine theta. So that means, i-multiply lang natin yung conjugate ni 1 minus cosine theta on both numerator and denominator. And this is one of the strategies in simplifying and proving trigonometric identities. Okay, now multiplying the numerators, we get 1 minus cosine square theta. Then multiplying the denominators, we get sine theta, times 1 plus cosine theta. So dito, we can use identities. Since si 1, si 1 minus cosine square theta, that is equal to sine, sine square theta. Then over sine theta times 1 plus cosine theta. Dividing this one, the sine theta in both numerator and denominator is cancelled out. So we left with sine theta over 1 plus cosine theta. And that concludes our proof that cosecant theta minus cotangent theta is equal to sine theta over 1 plus cosine theta. Para sa ating third example, let's prove that 1 plus sine theta over 1 minus sine theta minus 1 minus sine theta over 1 plus sine theta is equal to 4 sine theta times secant square theta. Now again, in proving trigonometric identities, ang first nating gagawin is to pick one side of the equation that is more complicated to simplify. Now in this case, obvious naman that the left side equation is more complicated than the right side equation. So that means mag-start tayo with 1 plus sine theta over 1 minus sine theta minus 1 minus sine theta over 1 plus sine theta. So that means we are going to simplify this one and see to it na ma-prove natin that this side of the equation is equal to the right side equation. Now, to do this, ang first natin gagawin dito is we go directly and combine the two fractions because the given expression is already expressed in terms of sine. And combining the two fractions, all you need to do is find the LCD. So what's the LCD, or the least common denominators? Of course, that is 1 minus sine theta, okay, times 1 plus sine theta. So that is the least common denominator. And doing the process na on how to subtract fractions, ang gagawin natin sa LCD is i-divide natin to each denominators and then i-multiply natin yung quotient sa numerator. So doing the process, of course, the LCD divided by the first term, no, the denominator of the first term, that is 1 minus sine theta. So that will give us, of course, that will give us 1 plus sine theta. Then 1 plus sine theta, i-multiply natin, or i-multiply natin sa ating numerator, 1 plus sine theta, and that will give us quantity 1 plus sine theta squared. Then doing the same process, no, sa second term, so i-divide natin yung LCD natin sa denominator, 1 plus sine theta, that will give us 1 minus sine theta, then si 1 minus sine theta, i-multiply natin sa numerator, and that will give us minus quantity 1 minus sine theta squared. Okay. Now, dito, ang next natin gagawin is we're going to expand, no, the numerator. So, expanding the numerator, we get, of course, let's expand this one. This will give us 1, okay, 1 plus 2 sine theta plus sine square theta. And of course, expanding this one also, that will give us minus 1, okay, 1, and then plus 2 sine theta, and then minus sine square theta. Then over, okay, over, of course, if you're going to multiply the denominators, that will give us 1 minus sine square theta. Okay, so let's simplify this one further, no? So as you can see, dito sa numerator natin, no, merong ma-cancelled out. Kasi, ma-cancelled out si, of course, ma-cancelled out si 1 dito, and also si sine square is also cancelled out. So that will leave us with 2 sine theta and plus 2 sine theta, which gives us 4 sine theta. Okay, then over, of course, itong si 1 minus sine square theta, this is, okay, this is a Pythagorean identity, which is equivalent to, of course, that is equivalent to cosine square theta. Okay, now at this point, we can rewrite this expression into 4, okay, into 4 sine theta, okay, sine theta times 1 over cosine square theta, which gives us to 4 sine theta times the equivalent identity of 1 over cosine square theta, which is a reciprocal identity, and that is equal to secant square theta. And that's the end of our proof that the left side equation is equal to the right side equation.